In our previous lesson, we looked at this concept of centre of mass, and we started to think about how the position of that centre of mass can affect the stability of a sports performer. So we're going to continue to look at that today, as well as understanding how we can maximise and minimise stability in sport by altering this centre of mass, as well as a few other things. So stability, you need to know this definition: the ability of the body to resist motion and remain at rest. The more stable a body is, the less likely it is to change its state of motion, and the easier it is for it to stay still. So a few examples, and you should already have an idea here from the reading that you've just done. If you could just consider the two diagrams, which would you think to be the least stable? So in this second picture, the height of the centre of mass is further from the ground. The reason for that is that the performer's brought her arms above her head, or she's raised her arms higher than they were. She also, if you noticed, is a taller performer than the first one, and therefore a centre of mass is further from the ground. She's also got a smaller base of support in the second picture because she's taken her hands off the floor, and therefore she has decreased her stability in the second picture. Again, if you consider which picture you would think would have the least amount of stability. So hopefully came up with this one. Obviously in the second picture, the line of gravity is now inside the base of support. In this picture, I would say the centre of mass is about here. And so the line of gravity, that imaginary line straight down, which is where we draw weight, the line of gravity is falling without the bit outside the base of support. The base of support here is obviously the hand. So with the line of gravity outside the base of support, we've got reduced and low amount of stability here, whereas in the second example, we've got our centre of gravity around here, centre of mass, sorry, our line of gravity here where we would draw weight, and our base of support is here, and therefore the line of gravity is falling within that. It's worth pointing out actually at this point that the line of the base of support in this sort of head and arm stand would be the head. We've got the head on the floor. We've also got two arms, two forearms on the floor. The base of support is everything within that area, so everything within the blue triangle. So a line of gravity that fell here is within the base of support. It doesn't have to be where the head or arms are touching the floor. Maybe a more simple way to point that out, if we stood on 2 feet, we've got 2 feet on the ground, our base of support is everything within the blue area. And so if the line of gravity falls here, then it's within the base of support. Here, it's within the base of support. Here, outside the base of support, okay? Consider the two boxes. Which would you say has the greatest amount of stability? So this one's tricky actually, because the mass of the boxer on the right is much bigger, so that's giving him an increased stability. But the boxer on the left is doing a lot to make up for that. So the boxer on the left has increased their base of support by widening their feet. This boxer, I think it looks like this back foot is off the ground, or if it's not, there's very little weight through it. Whereas this performer has widened their base of support. They've got weight through both of those feet. They've also bent their knees to get really low to the ground in order to maximise their stability as much as possible to overcome this player's or this performer's weight. So both of them are doing quite a lot to maximise their stability. In sporting actions where an athlete needs to remain still, they will try to maximise their stability. But In any sporting action where movement is required, the athlete will be doing something to minimise their stability. So it's a common misconception to think in sport stability is good. In sport, stability is good where performers want to try and remain still. But in sport, stability is bad when we're trying to move. If we're trying to accelerate, we're trying to change direction, we're trying to rotate, then we want to do something to minimise our stability and make it easier for us to move. So in these examples, these performers have minimised their stability in order to maximise their performance, making them easier to move, to specifically accelerate, change direction or rotate. So in this example, the performer has minimised their stability by moving their centre of mass outside of their base of support and therefore decreasing their stability. This runner has raised their centre of mass. It was here, now it's up here, to decrease their stability, making it easier for them to accelerate when the gun goes. This performer has moved sort of leant over to the side, moving their line of gravity outside of their base of support and therefore minimising their stability, making it easier for them to change direction. So we need to be able to speak very clearly or write very clearly in the exam about the 4 factors affecting stability, and we might need to say how the factor is being used to maximise stability or to minimise stability. So first one, height of centre of mass. The lower the centre of mass of a body, the more stable it is. So when a gymnast lands, they bend their knees to lower their centre of mass and increase their stability to stop themselves falling over. Can you ever think about when we might want to reduce stability, given a sporting example of where the height of centre of mass is used to is increased in order to reduce stability? So we can use this example of the gymnast at takeoff, raises their arms, raises their knee, jumps into the air, all of which raises their centre of mass away from the floor, decreasing their stability, making it easier for them to rotate. Another good example is that sprinter in the set position raises their centre of mass, brings it higher in order to, it's probably not that high, in order to minimise their stability, making it easier for them to accelerate. Factor number 2, size of base of support. The larger the size of the base of support, the greater the stability. A balance in gymnastics becomes more stable where there are more points of contact with the floor. When these points of contact are larger and when they are spread wider apart, the balance is more stable. Can you think of a sporting example where the base of support is reduced in order to reduce stability? So we could use this balance as an example. The gymnast may choose to perform a balance in their routine where the base of support is small to reduce stability, making the balance harder and therefore worth more points. So in this example, the base of support is just between the 2 hands here, and the hands are quite small. Whereas in this example, it would be the whole of the 2 arms on the floor, and that would be a larger base of support, making this balance easier and worth fewer points than this balance. Obviously, if they decided to do a one-handed handstand, that would reduce the base of support even further and make that balance even harder to perform. Okay, factor number 3 is mass. The greater the mass of the body, the greater the stability. So a rugby player with a large mass is more stable and may be harder to take down in a tackle. Can you think of a sporting example where a performer minimises their mass in order to reduce their stability and increase their performance? A good example, again, gymnastics is a really good one for this. A gymnast keeps and maintains a small body mass in order to minimise their stability and therefore make tumbling in their routines much easier. Final factor number 4, line of gravity compared to base of support. So if the line of gravity is within the base of support, the stability is greater. Remember, this line of gravity is an imaginary line that we would draw down from a person's centre of mass. It's where we draw weight. So the centre of mass is here. The line of gravity is this imaginary line that comes straight down, and it's where we draw our force arrow of weight. And in this one that I've just drawn here, it's falling directly within the base of support. The base of support is here between the 2 feet, and the centre of mass and therefore line of gravity is right in the centre of that base of support, meaning this person is as stable as they possibly could be in terms of line of gravity compared to base of support. If they leant slightly this way, move their centre of mass slightly out here, their line of gravity would still be within the base of support, but now it's closer to the edge, so they are less stable, but still quite stable. If they were to lean right over and bring their centre of mass out here, their line of gravity would then fall outside the base of support and therefore minimising this performer or this person's stability. So a netball shooter keeps their line of gravity directly over the centre of their base of support while shooting, so that they're shooting from as stable a position as possible. Can you think of a sporting example where the line of gravity is taken outside of the base of support to reduce stability and therefore increase performance? This is examples that we've looked at in previously. So we've got our trampolinist or our gymnast either leaning backwards or leaning forwards at takeoff, which minimises stability because the line of gravity is falling outside the base of support, the line of gravity outside the base of support to make the rotation easier to achieve. And finally, I think, an example of a sprinter here. Now the gun's gone, they lift the hands off the floor and they're leaning forwards, which means that their centre of mass here is probably about here. It means that the line of gravity, this imaginary line straight down from the centre of mass, is falling outside of the base of support, which reduces their stability, making it easier for them to accelerate on the gun. And I've got that example there again of the footballer, centre of mass, he leant to the side, brings his centre of mass over here, which means his line of gravity, which is that imaginary line straight down from the centre of mass, is falling outside of his base of support. That's reducing his stability, making it easier for him to change direction. In reality, actually, in sporting scenarios, there's often more than one and very often all 4 of these factors that are affecting stability being implemented by the athlete. So if we look at this example again of our trampolinist taking off, they've moved their line of gravity outside of the base of support by leaning backwards. They've raised their arms above their head, which raises their centre of mass. A trampolinist would maintain a reasonably low mass, and they're also jumping with their feet really close together in order to minimise their base of support. And all of this minimises stability at takeoff and allows them to produce movement, in this case to produce rotation about the centre of mass. And remember that rotation, that angular momentum, is generated because the action force is applied and then the reaction force is generated outside of the centre of mass, creating an eccentric force. Again, when we're maximising stability, often we're putting all 4 of these factors affecting stability to good use. So the rugby player in this case, they've moved the feet. I know we can't see the second foot, but we know where it is. they've moved their line of gravity inside and right to the middle of their base of support. So their centre of mass is somewhere around here, isn't it? If we drew their line of gravity down, it's falling right within their base of support, which is increasing stability. The performers also bent their knees, which is lowering their centre of mass, causing greater stability. They've also taken their feet wide apart, which is increasing the base of support. And rugby players tend to have relatively large masses in comparison to other sports performers, which helps them to maximise their stability. Stability is a massive factor in rugby, and that's one of the reasons that rugby players have a larger mass in comparison to lots of other sports where stability is less important. So all of these together has made this rugby player harder to tackle, harder to take to the ground. So I want you to pause the video and have a think about your sport. Try to think about times in your sport when players look to both minimise and maximise stability, and think about how they practically achieve it. I want you to write out 2 examples in your sport where the performer is maximising their stability, and 2 examples where they're minimising their stability, and state how they are achieving it. Remember, it's possible that the performer will be using more than one of the factors to achieve either their decreased or increased stability. So pause the video, have a go at those 2 examples. Now we're going to look at some past exam questions. Hopefully these will be relatively simple. We'll look at them together and I'll talk you through the answers. So each time, we've done this before, each time write the question and then you can choose to pause the video, write your answer and then play the video and check whether you got the answer correct, or you might want to listen to the question and then the answer and then write out your perfect answer in your own notes. So question number 1, which one of these balances is more stable? 1 mark. Hopefully you can have a go at that without the mark scheme. So pause the video now. So the headstand is more stable than the handstand. This question didn't ask you why. But obviously the reason is because in the headstand we've got a larger base of support because we've got 3 points of contact with the floor, giving us a great base of support, whereas in the handstand we've only got 2 points of contact with the floor and therefore a much smaller base of support. Question number 2, define centre of mass. Explain how a rugby player can apply knowledge of centre of mass to increase their stability. So the first thing that I would point out to you here is there are 2 parts to this question. You need to remember to answer the first. It's a really common mistake for students to go straight into explaining how the rugby player can apply knowledge of centre of mass and forget this first mark. There are going to be sub-max marks on the mark scheme. 1 mark for defining centre of mass and a further 3 marks for thinking about how they can use the idea of centre of mass to increase their stability. So pause the video now if you want to have a go without the mark scheme. Okay, so we've got 1 AO1 mark, 1 mark for giving a fact, and 3 AO2 marks for applying to this example. Okay, so the definition of the centre of mass, the point at which the body is balanced in all directions, should have been your answer. Explain how the rugby player can apply their knowledge of centre of mass. The first one is that they should maintain stability by having their centre of mass directly over their base of support. You might have gone on to say that that means the line of gravity is therefore within the base of support. But the question is about the centre of mass, so you needed to talk about the centre of mass in your answer. So the centre of mass is directly over the base of support, and then you've probably gone on to say that that means the line of gravity is within the base of support. And then also we've got the rugby player in the question, so the rugby player has to be in our answer, and we're using the rugby player to explain. So To say the centre of mass must be over the base of support is just identifying a factor. Until we bring the rugby player into it, we're not explaining and we're not actually answering the question yet. So, rugby player lowers their centre of mass by bending their knees and thus can increase their stability. You may have said the player increases the area of their base of support by widening their stance. And that's still to do with centre of mass because you might have brought it on from this idea of the base of support. Yep, stability's increase of the line of gravity is within the base of support, and therefore you might have said that the player leans in a certain direction or maintains their centre of mass within the base of support when they're in a tackle in order to maximise their stability. So it would be 1 mark for one of these and then 3 marks for any of these points. Question number 3, explain the factors that affect stability in physical activity. This should be really straightforward, but we need to explain, not simply list, okay? So we're going to say what the factor is, but we've got to say how it then affects stability in physical activity in order to get the marks. So, you know, for example, just saying height of centre of mass, etc., is not going to get you the 4 marks here. Okay, so you can see the factors on the mark scheme are listed, but they are then explained in order to get the mark. So height, this is a follow-on question. This is a follow-on question from this question, which is why the mark scheme reads like it is. So height, greater stability, i.e. this performer has a greater stability than this performer because their centre of mass is lower. So in the headstand, higher in the handstand. Base of support, greater stability because the area of base of support is larger. So if you've said named base of support as the factor, but then said if we increase our base of support, then we have a increased stability, then that gets you the mark. Similarly, you might talk about points of contact with the floor. I would say these two are interchangeable and it's better to use size of base of support because that's the better point. I wouldn't use both of these in an answer. I would think often it would be the same mark on the mark scheme because increased points of contact is increasing the base of support and therefore increasing stability. And you might have said mass and then gone on to say the greater the mass, the greater the stability. Line of gravity in comparison to base of support. So the nearer the line of gravity is to the centre of the base of support, then the greater the stability. And body shape, you might have said, obviously didn't need to say that to get all the marks here. This was a 4-mark question. But if we distribute parts of our body in a certain way, we can affect our stability. So if we raise our arms, then we're raising our centre of mass and therefore reducing our stability. Okay, we're going to do something a little bit different now. So we've got a question here and then 2 possible answers. I want you to read the 2 answers and think about how many marks you would allocate. So the question is, good stability is important in team games. Using a game of your choice, explain the factors that need to be considered to increase stability. 3 marks. So how many out of 3 would you give for answer 1? How many out of 3 would you give for answer 2? Pause the video, have a think. Okay, so let's go through it together. So as a rugby player prepares for a tackle, they need to make sure they lower their centre of mass to make them more stable on contact. Mark. They also need to give their support a wide base. That would get a mark. Their line of gravity should be over their feet. Yes, that's fine. Also, the more weight the player has, the more stable they are. That's correct. It wouldn't get a mark because it's obviously a 3-mark question. And in fact, what this person really has done is waste time by saying 4 points for a 3-mark question. Let's have a look at the second answer. A gymnast needs to be stable on landing. So first of all, they need to lower their centre of mass on contact with the ground. Then they will make sure their base of support is wide to increase stability by landing on 2 feet rather than 1. Finally, their line of gravity needs to be directly over their base of support. Hopefully you've recognised what's wrong with this question. Okay, the question says in team games, and this answer is about a gymnast. So actually the answer's perfect in terms of the fact that they've said everything right about centre of mass and base of support, but they've answered the question about a gymnast, and so this answer would receive 0 marks. Okay, and that brings us to the end of our stability lesson.